Yeah, so we'll begin with one problem. Let's say in this problem you are given a string s of length m, and a condition is like string has lowercase alphabets. Let's keep it simple. So only lowercase alphabets are there in the string, and we have to answer q queries, and each query is of the form. Let's say it gives L1 R1 to L2 R2. And what we have to answer for the query is we have to tell if we take substring from index L1 to R1 and we take a substring from L2 to R2, both inclusive, we have to tell whether they are equal or not. So the output has to be yes or no. Is question making sense to everyone? Okay, only one person is saying it is making sense. For others,
Yes, sir.
cool. So let's take a look at few queries on this string. So let's say on this string, if I give you those queries, so let's say if I tell you 0 to 4 and 5 to 8, what is the answer for this query?
Not equal. No.
Answer for this you're saying is no. Okay, I'm enhancing the string a little more so that I can have few more queries. Yeah, what is the answer to this query? Yeah, so for this query, we can observe that answer is yes, because 11 to 13, it is ing. Same way, if I give you one more query, let's say the query is 5 to 8, and then query is 14 to 17. Then what is the answer?
Yes.
Answer is yes. And if I give you a query like, let's say, 1 to 4 and 9 to 17,
No is the answer, sir.
the answer is no. Yeah. So this is the question. Let's say in this question, our string length and number of queries is 10 to the power 5. That means these are the queries we have to answer, and string is also big enough. And we want to solve this problem efficiently. If we go with brute force idea, if we go with brute force here, every query will take how much time?
Order of n.
Yeah, each query will take n time. So can we say overall queries will take q into n? And space required by brute force will be what?
Constant space.
Constant, because we don't need any extra space. We are just managing with a loop for every query. Okay. So this, based on the constraint, we can directly see that this is no-brainer. This is going to give TLE anyways. So we need to find an efficient solution. So we will talk about a topic today which enables us to solve this problem as well as many similar questions on strings efficiently. And before we move forward, I just want to call out what are the prerequisites for this session. And we will quickly revisit the prerequisites also so that we are confident that those topics I don't have to repeat and we don't have to kind of think back about them if we call them out. So first of all, we need to know about modulo arithmetic. And in modulo arithmetic, we don't need modulo inverse. If I leave modulo inverse aside, rest of the modulo arithmetic, we all feel comfortable with.
Yes, sir.
Yes, okay. Second thing is, we need to know how to answer range sum queries efficiently. Range sum queries on 1D array. How do we answer range sum queries? Call it static range sum query. Array does not change. You have to answer L to R, what is the sum of the elements?
Using prefix array.
Using prefix sum array. Yeah. So prefix sum. We can also solve this problem using suffix sum.
Or a segment trees also we can.
Yeah, segment tree are more useful when we have dynamic range sum queries. Yes, that is there, but we will not need segment tree for today's discussion.
Okay, sir.
Yeah. So if this much fundamental is clear, like we know prefix sum, we know suffix sum, we know range queries, and we know modular arithmetic, that is good enough for us to delve into what we are going to discuss for today's session and for solving this problem. Okay. Now talking about string hashing, that is the topic that we are going to discuss. So if I say that we are going to talk about string hashing, first of all, we need to understand what is the motivation behind it, or like why this is going to be useful. So idea or you can say the motivation comes from one part. If you have to compare two integers, how much time is required to compare two integers?
Constant time.
Yeah, comparing two ints requires constant time. But comparing two strings requires
Length of the string, order of length of the string.
strings or parts of a string. Two parts of a string requires order of length of that part time. So the idea comes here, why not? What if every string is converted into, if somehow we form a mechanism where a string can be converted into an integer, then rather than comparing two strings, we would be comparing two integers, and we know that is faster. This is ultimately the crux of what we are going to discuss. So what we essentially do is we come up with some logic, some idea, which we call as hash function, which if we apply to a string, it should result into an integral value, and that integral value we call it hash or call it hash value. So we will, like going forward, we will use these terms frequently, like I give you a string, give me the hash of the string, or give me hash value of the string. This entire process of converting a string to a hash value or a hash integral value, we call this as hash. The goal is about understanding the nitty-gritties of it, what are the things involved, so that we see like how it is applicable to solve the problems that we are going to discuss. Okay, cool. So now question comes, how can we convert one string to an integer? There are many ways. I'll not go into theoretical details of it. We will go into most applicable aspects, most practical aspects, so that we keep our discussion focused on solution rather than roaming around in academic theory and doing a PhD in that. We will learn what is necessary, what is required. Okay. So goal is like, how do we convert this string into integer, and that too to solve problems efficiently and avoiding the issues. Now, this also will draw motivation from the numbers. So when I say, let's take a decimal number, let's take the number as 5296. This is a decimal number. Decimal number has how many digits? Any decimal number. Decimal number is based on how many digits?
Digits.
Sorry?
10 digits 0 to 9.
Yeah, 10 digits, 0 to 9. So 10 is what we call as base. So what we do is we use the idea, we say, hey, we can write it as, this number can be written as 5 into 10 to the power 3 plus 2 into 10 to the power 2 plus 9 into 10 to the power 1 plus 6 into 10 to the power 0. This is what we use as basis of representing a number, or this is how we construct the number in decimal number system. Same analogy if we use, and if we try to apply same analogy to a string. So I give you a string. Let's say I give you a string PQRST. Now, thinking of PQRST, if I ask you, how many, here we talked about how many digits are there in decimal number system. In alphabets, where small letters are there, how many alphabets are there? Lowercase.
26.
26. So can I say base is 26 now? This is A to Z, so it is 26. That means we should be able to express it as P into 26 raised to the power something plus Q into 26 raised to the power something. What will be P into 26 raised to the power?
5.
Think about, will it really be
Oh,
5?
4. 4.
Yeah, it will be 4. Because see, after 5, there were 3 digits, so we wrote 10 to the power 3. After P, there are 4 alphabets, so we write power 4. Power 3, 26 to the power 2, S into 26 to the power 1, and T into 26 to the power 0. This is a simple way we can write a string and we can kind of get some number. Now, if we do this, what will we write as a number in place of P? Because they all should be replaced with their numbers. So what do you think would be integral value we will use in place of them?
ASCII value.
Yep, we can use direct ASCII value. So that is definitely one option. The ASCII value of P is what? Small p. What is ASCII value of small a?
97.
97. And small z is 122. Now tell me what is the ASCII value of P?
112.
112, that is right. Awesome, Suhas, your human computer, that is good. Or you searched online?
Added, sir.
Added, very nice. Okay, this is 112. So this, of course, I have written sequential numbers, so 113, 114, 115, 116. So looking at it, we definitely got a way that very logically we can convert a string into an integer, right? So it is not kind of a tough task to convert a string to integer. And now this integral value that we have, it can act as hash of a string. Yeah, and this hash will be unique. Everyone agrees that two strings will not have same hash value. Is this making sense?
Yes,
sir.
sir.
Yep. So this is a good hash function. So two different strings will not have same hash value. That means there will be no collisions, or there will be less collision, because same way in integers also, if you focus on integers, two different numbers are different because we are converting them into by base math into consideration. Okay. Now this was one idea. We directly use their ASCII values to kind of represent here. Another option we had is if we want to keep our computations shorter, what we could have done is A could have been translated into 1, B into 2, C into 3, and so on, Z into 26. We could have used that also. If that is the way, then P will be what? Basically, I'm saying rather than using their ASCII values, we could have mapped them into 1 to 26.
16 P.
P will be 16 or 15.
Mhm.
15.
15. MA is 13. Okay, 14.
Yeah, 14, 15, 16, what?
Ah, 16, sir.
16 it should be, yeah. Because in 97, you add 15 to get it. In 1,
Hmm.
you add 15 to get this. Okay, so this is... So ideally, this will also be a good way that we could have, in place of using their ASCII values, we could have used that. Either way is fine. But right now, like ideally, we can choose anything. I don't want to keep discussion vague, so I'm going to stick to 1. Okay, we'll directly use ASCII values. And reason, can somebody tell why I'm sticking to ASCII value? Why I'm not going with 1 to 26? What is the reason? I believe that's a better choice. Why? What makes me say it's a better choice?
Somehow we are
Finding
reducing.
ASCII value of a character is easy.
Sorry, getting ASCII value is?
Finding ASCII value of a character is easy.
Okay, fair. But converting them to 1, 2, 3 is also easy because what you will do is C minus subtract ASCII value of A and add 1 to it. This formula will give you the mapping to 1 to 26 also. So this is also easy. Of course, this is not a one-liner. That is one-liner. So ease of coding is definitely like, I'll accept your argument. But that is not the basis for me to say that because once we understand this part, converting it to 1 to 26 is also easy. But still, I said that is a better choice to stick to ASCII for now. Why?
Like somehow we are reducing the collisions. For example, a string A
Uh-huh.
is will generate the same ASCII like A will generate the same ASCII of C.
Why? If you go with the second approach, you're saying
Yes, sir, in second approach.
AA. Let's see. When we have AA, in AA, what you will do is you will use 26 to the power 1 into 1 plus 26 to the power 0 into 1. For A, I have used value 1. But for CC, you will say it is 26 to the power
Single
1
C.
into... Huh?
Only one C.
Okay, only one C. Then it will be 26 to the power 0 into 3.
Okay.
Is it same?
No.
It is not same. See, by definition itself, like I don't think we will get collisions over here. If we would have used A map to 0 and this map to 25, then what you are saying is right. Then this would have totally become 0. That would have been disastrous. So we used 1 to 26. Yeah. Any other reason? Harshita? Hussain? Yeah. Okay. No response. If my string contains lowercase as well as uppercase letters, then what do we do? Will we be able to apply this idea of mapping?
No, sir.
Okay, one answer is no. Second is no, we can still apply. We can check. If it is lowercase, use this formula. If it is uppercase,
We'll change it to capital.
use this formula plus 27 so that you map uppercase to 27 to 52. But what if our string contains other characters also? Then for every kind of imagine if a string contains digits also, string contains special characters also, then every time we do not want to keep changing our way of computing hash, right? But if you stick to ASCII value, you know every character has a unique ASCII value. We do not have to worry about that much. Is this argument making sense? That sticking to using ASCII value enables us to process any kind of string. We do not have to go with the assumption that my string contains only lower alphabets. Yeah.
Yes, sir.
Yes.
Perfect. Okay, so we got some way using which we know we can hash any string into integer. So this looks to be a good hash function. And yeah, but in this hash function, if we apply this hash function and try to solve this problem, I just want to ask you, if my string is of length 10 to the power 5, imagine if string has length 10 to the power 5, what do you think can be the maximum hash value? What would be hash value of a string considering only lowercase alphabets? What is the max hash value possible for string of length 10 to the power 5? Only lowercase, because we are keeping to only original problem.
It will be greater than 2 power 64 clearly.
Okay, so we started to see a challenge that we have a good formula, but the value will not fit into long. Value won't fit into int or long anymore. Yeah, and this value will be too high because the whatever first alphabet is, like we think of the worst case string, which is all z's are there. The ASCII value of z we know is 122. So you will say 122 into 10 to the power 5 minus 1. Is this how we will write? Or this will
No,
be,
sir. 10 power 5 minus.
it will be like this.
Hmm.
Plus 122 into what? 10
10
to the
power
power.
5.
No, sorry, my bad. This should be
20.
26 raised to the power 10 to the power 5 minus 1. Yes. Plus 122 into 26 raised to the power 10 power 5 minus 2. And this is going to be huge value. Even a single number is going to be a huge value. So this is not going to work for larger strings. But we have no way to come up with a hash function for larger strings. So some sort of maths we have to apply. So what do you think we should do?
Modulo.
Yeah, we should use modulo. And that is where we said like modulo arithmetic is required for us to proceed forward. So what we do is we define our hash function will be in such a way that we find a hash, but we do modulo. What is a good m value that we typically use for doing modulo?
10 power 9 plus 7.
Yeah, 29 plus 7. And you know the reason we use this value is because it leads to giving less collisions. If I talk about probability of getting collision, probability of collision. Imagine if you do mod 2 for some values, let's say 1 to 10, if you do mod 2, what are the possible values we get as outcome? If you
0,
just
1.
take only 0 and 1 you get. So can I say probability is is 1 by 2 because every other number is colliding. It's 0, 1, and then again comes 0 comes. Same way, if I use m value as 3, what will be probability of collision?
1 by 3.
Yeah, probability
You
will
get
be 1
0,
by
1,
3.
2.
Same way, if our m is 1e9 plus 7, then what is probability of collision?
1 by 1e9 plus.
1 by
Yeah.
1e9 plus 9.
1 by 1e9 plus 7. So can I say taking the larger value reduces the probability of collision?
Yes,
Yeah.
sir.
Yes,
And if that larger value is prime, that is even better because when you divide, there are no common factors, right? Kind of you get co-prime. So having mod as a larger prime number is always a good idea. So large prime per mod is better idea. Okay, so now our goal is what we do, we define our hash function to be in such a way for a string that we will apply the same maths that we did over here, but we will keep doing mod at every stage. Like p into 2 power 26 power 4, do a mod. Q into 26 power 3, do a mod. And then keep adding. So using modulo arithmetic, we can compute the hash. Okay. Now another thing, because we talked about collisions and primes, research and theory also says that for 26 also, for 26 alphabets also, choosing base as a prime number is better. Choosing a prime base is better. Choosing a prime base is better idea. So if I ask you, tell me a number which is prime but which is bigger than 26, which number would you choose for that?
29.
29. 29 is a prime number. Yes. For 26, bigger is 29. After 29, next prime number
31.
is 31. Then we have 37. So basically choosing any larger prime than base is a good idea. Okay. So for lowercase alphabets, this seems to be a good choice, or any number bigger than this seems to be a good choice. What if lower and upper both are there? Then what prime number will you choose? If your string contains lower and upper both, and you have to choose a base.
53.
Yeah, 53 is a larger prime number than that. 59 is a prime. Yeah. Anything greater than 53 is better. Yeah. And imagine if we are supporting every character, not only lowercase and uppercase, then which prime would be better to choose? Total, how many unique characters are there?
52 characters.
52 are alphabets. If
Yes,
you
sir.
add digits to them, if you add hash, at the rate, dollar, I'm asking overall how many characters are there?
That will be a maximum value of ASCII.
Yeah, what is that? Okay, in ASCII, what is the size of ASCII table?
256, I guess, sir.
Yeah, 256. Out of them, half are printable characters, half are non-printable characters. So it is 128. Okay, any number bigger than 128 is a good idea. So tell me a prime number bigger than 128. Yeah. 131 is a prime. 137 is a prime. So this becomes a good choice. Yeah. So ultimately the crux is depending on the alphabet size, we can choose any good prime base rather than choosing the actual base. It's better to go with prime base because there also you're actually increasing or you can say you are having less probability of collision. So you are decreasing the probability of collision. Okay, so that means if we now redefine how we are going to compute hash of a string, then we are going to use two terms. Let me call it as PB. I'm calling it prime base. It is not the actual base, but we are choosing a prime number which is a little bigger than the base of our alphabet size. So it will be better rather than calling it with two letters, I call it with one only. Let's call it P. P is our prime base. And we define another thing M, which is our mod value. Okay, so we choose two numbers, both primes. And now if we have to define hash function for a string, and a string is of length 1, string is of length n, then S0 will be multiplied with what? S0 will be multiplied with what? You saw earlier how we wrote
P power
Yeah.
0.
Mhm. Did you really multiply P with 2 power 26 power 0? Did you really multiply 5 with 10 power 0?
Mhm.
Yeah. S of 0 will be
P
multiplied
power-
with what?
P
P
power
power?
length of string minus 1.
Yep. P power n minus 1. Yep. Let's take n as length of the string. Let's define third variable also. So we are saying, hey, it will be S0 P to the power n minus 1 plus S of 1 into P power
N minus 2.
all up to S of n minus 1 into P power what?
0.
0. Okay. And we also defined that this entire thing we have to do mod n.
Mod n.
This becomes our hash function. Okay, in mathematical notation, if we have to write, we can write it as S of I into P of something, where I changes from 0 to n minus 1. So tell me what is P power I should write?
I.
No. Is S0 into P power 0? Yeah, generalizing above thing.
I minus 1.
P power I minus 1? No.
N minus
I-
I
N
minus 1.
minus I plus 1.
N minus?
I plus 1. Or N minus.
N minus I plus 1. Is that what you are saying?
Yes, sir, but if I is 0, then N plus 1.
What should it be
So,
then?
it should be N minus I
N
minus
minus I
1.
minus 1.
Yes, it is N minus I minus 1. Yeah. Okay. Yeah, so this is our idea that this is how we will compute hash of our string. Okay, and since modulo is in picture, so we will do modulo at each stage. Okay, now what I want you to do is I'm giving you a small string and I really want you to calculate the literally value of this. Let's say, okay, now I don't want to use P because P we are using like a prime base. So let me give you a string as BCDE. Yeah, can you compute with pen and paper, compute the actual value of this string, keeping, let's give some numbers. Let's see, prime base we keep as 29 only. Okay, and n you already know, n is 4 for you. And mod we will keep 1e9 plus 7, but you will not require to do mod because the value I have given you a small string, it will not overflow. So you will ideally you will not have to do mod. Yeah. So can you work out and tell me what is the actual integral value that you are getting for this? And yeah, for each character, you will be using their ASCII values. So you're not going to use 1, 2, 3 for mapping. Use ASCII values. Okay, Harshita has sent some value. Waiting for others' responses. Yeah, so B is 98 into 29 raised to the power 3 plus. It is 99 into 29 raised to the power 2. 100 into 29 raised to the power 1 and 101. Okay, so I received 4 answers and all 4 of you are saying it is 2, 4, 7, 6, 3, 8. So ultimately, if you see, we are able to achieve integral value for this. Mod is not required because this was a smaller string, right? Now, if I ask you to write code or a function which can compute this value using modular arithmetic, will that be easy? If we write it like hash function of string s, and you should be returning a hashed value of this. That is easy to do. Yeah, can you quickly write this code? You have to keep modular arithmetic in mind because this string can be bigger also. Yeah, so quickly complete the code and let me know once you are done with this code.
Sir, here we need to take the prime base 1e9 plus 7, sir.
Yeah, I have written above if you see. So P is this, M is this. Only N has changed for you now. And when you're writing code, you can just treat their variables for you. You can change their values also. So rather than writing into 29, it's better to use into P. P is a variable. Okay, Pranita is done. Pranita, while others are doing, I want you to dictate your code, what you have written. Just line by line, just speak up. Yeah.
Long sum is equal to 0.
Okay, long sum is equal to 0. I'll call it H because it is hash. Okay, then
Int n is equal to s dot length.
int n is equal to s dot length.
Int p is equal to 29.
Okay, so you define variables. P is 29. Mod will be int of 1e9 plus 7.
Yes.
Okay,
And
then
for loop,
okay,
for
for
loop,
loop for
int I is equal to 0 to I less than s dot length, I plus plus.
we can use n. You have taken n already. I plus plus. Okay,
Sum plus is equal to
sum plus is equal to
math dot power, math dot
math
POW or
POW of
p comma I
p comma I
mod m
mod m
plus
plus
s dot caret I
s dot char at I
mod m
mod m
whole mod m.
whole mod m. Okay, and finally return sum. Okay, in place of sum, I said I'm using H. So let's use it. This is the full code.
Yes.
Okay. Pranita, there are mistakes in the code. I want you to think about what makes me say that this code is buggy, it will not work. Think about there are some mistakes you have done, and I want you to figure out what is that mistake and how you will correct it. Okay, Hussein, is your code different than this?
I also applied mod operation for h
Mod operation at?
while adding h to this product.
Okay,
We need to
so
apply mod operation.
you are saying you are cautious about this, which is good because that is definitely one mistake. So rather than doing this, you have done h is equal to h plus, then you have done math.pow p comma I mod m plus s dot caret I mod m, and then you have done overall mod m. Is that what you are saying is your code?
H mod m plus the product mod m and whole mod m.
Acha, so you have done here like this. Is that correct? Or you are saying you wrote h mod m separate, this separate,
Sir.
third separate, and then overall mod m.
Yes.
Okay. Suhas, what is difference between their code and your code?
Instead of using power function, I'm multiplying p with 29 in the for loops
Very nice.
and initialize the p with 1.
I want Pranita and Hussein to think, can you really use math.pow function where p is 29 and I is somewhere, if I becomes 1000, what will POW return? When if the string length is 10 to the power 5, then I becomes 1000, 1001, 1002. Do you really think that math.pow would do modulo computation and return?
No, sir.
No, sir.
Okay, so that is a huge mistake, right? Because that will lead to wrong answers. That is the reason we learn modulo arithmetic, so that we do not use built-in POW, because POW will not be able to compute answers beyond the int or long range. Okay, so Suhas has taken care of this. Suhas will come to your code also. That is good that you have addressed this. Harshita, what about you?
Same as Pranita, sir.
Same as Pranita. So you understand the mistake in math.pow?
Yes, sir.
Okay, Suhas, go ahead, dictate your code.
Same, sir. Only change is okay. From first I should dictate, sir.
Yeah, no, for loop, only for loop, because that is where your code is different. For int I is equal to,
0,
okay,
I less than s dot length, I plus plus.
I plus plus. Okay, earlier also did I write? Okay, earlier I wrote n. So here also better I write n.
Okay.
Okay, then what did you do?
Initially I have taken p as 1, sir.
Okay, initially you have taken p as 1.
I have considered p as long.
Okay, p is
And,
long.
Sum
Okay.
and sum is equals to
Okay,
h mod m plus
h mod m.
s plus s dot character of I, character
Okay,
return,
just for shorthand, right now I'm writing si. Just treat like it is s dot caret I. Okay, into.
minus character a.
I said we will not do conversion to one-based indexing. We will use ASCII values.
Okay, sir.
So we will directly use the ASCII value. We don't want to do that mapping to 1, 2, 3, 4. Okay.
Okay.
Then
Into p mod m, whole model, and also whole model, sir. P is equals to p into 29 mod m. In that for loop, mod m.
okay. This also is incorrect.
The p is going in reverse order.
Yep. Here you are actually doing. You are doing s of 0 into p of 0.
Yes, sir.
S of 1 into p of 1, but that is not what we defined our hash. Our hash was, if you really see, s of 0 is multiplied with p of n minus 1.
In that case, like we can reverse the for loop.
Yeah, we can reverse the for loop. We can come from n minus 1. That would fix the issue. So you can actually start with n minus 1, I greater than or equal to 0, I minus minus. Now this is fair that you are multiplying that with 1, and then you will, so ultimately what you are doing is the way we did here. So you took E's ASCII value multiplied with 1, then you change 1 to 29 by multiplying it with 29, then you took ASCII value of D multiplied with 29, then you upgraded it to 29 square, then you upgraded it to 29 cube. Everyone agrees that this is the right function to, correct function to write, and this takes care of modulo arithmetic also well. So do we realize the mistakes that we have made and learn from it?
Yes, sir.
Okay, it's return h, sorry, my bad. This is one way of writing. What is the time complexity of this?
Order of n.
Yeah,
Order
it is
of
order
n.
of n. And spaces?
Constant.
Constant.
Yep. So why I asked you guys to write it, this is not the only way to write this function. This is one way of writing the function. Another way we could have written the function, same function is the first number you have to multiply is you have to multiply that with 29 raised to the power what? The first ASCII value. Imagine if you had to process it from left to right, then you directly needed 29 raised to the power 3. In some people cases, they used built-in power function. But what if I tell you, hey, you could have pre-computed every power of 29 with modulo in advance. Would that be a good idea?
Yes, sir.
So you
Yes,
could have
sir.
computed power of 29. 29 raised to the power 0 is 1. 29 raised to the power 1 is this. 2 is this. So take an array, pre-compute and store those values. Okay, so that is the second implementation I'm talking about. Yeah, so you can say, let's say log prime powers is equal to new log of size n. N is length of the string. And you could have, you know very well that you can do pp0 is 1. And then your for loop would be from I is equal to 1 to n minus 1. And you can directly say pp of I is equal to pp of I minus 1 into the value of p, which is 29. And you are doing mod m over here because you will need these modulo powers. Once this is done, you could have directly gone from left to right. In the string case, you could have gone from I is equal to 0 to n minus 1. And then you could have directly said, hey, my h is equal to h plus s of I into pp of what? Yeah, guys, pp of what?
N minus I minus 1.
N minus I minus 1. This is the formula you came up with earlier also when we wrote the summation here. Yep. So we are just doing Si into P of N minus I minus 1. Yeah, if we would have gone via this route, what would have been time and space complexity?
Order of n time complexity. Space complexity is order of n.
Yeah, space this time became M. What is time?
Order of n.
Order of n.
Yeah, big O wise it is N, but practically speaking it is N
When
plus N, because we are now doing 2n computations. One for pre-computation of powers and second for using that computing the hash. Okay. Now, there was a third way also. Third way we could have computed is, let's see, long hash is equal to 0. What we do is for I is equal to 0 to n minus 1. What we would do is we would say h is equal to h into, rather than writing 29, I'm writing h into p plus s of I. Would this also work? Yeah, guys, what do you say? Would third method also work fine? I gave you B, C, D, E, right?
Yes, sir.
Okay, let's say you have B, C, D, E. Initially, our H value is 0. So When we consider B, what happens? It becomes 0 into 29 plus B. So eventually it becomes B only. Is that right? First iteration of the loop when I is 0. When I is 1, what happens? Then it becomes B into 29 plus C. Okay. Then when we reach second index, that becomes B into 29 plus C into 29 plus D, which is no different than B into 29 square plus C into 29 plus D. Yes. And in last iteration, what will it make? It will make it B into 29 cube plus C into 29 square plus D into 29 plus E. This must be a familiar thing in some mathematical programs. Where do we use this kind of idea? Or let me ask you a different question. How do you write program for reversing a number? How do you reverse an integer?
We'll mod it with 10, take the last digit.
Okay, you take the last digit. This is your last digit. Ideally, when you are reversing 2159, you take 9 out and using 9 you create reverse number. How do you create reverse number? This is your n. You have to create Rn. How do you create Rn? Initially Rn is 0.
We'll
What do you
multiply
do?
with 10 and then add 9.
Yeah. So 0 you multiply with 10 and add 9. So it becomes 9. And this you remove then. It becomes 215. Then what do you do?
Remove 5
You
and
take 5. And how do you add 5 there?
9 into 10 plus 5.
Then you are left with 21. Is third approach similar to that?
Yes, sir.
Here the base is not 10, so base is P, and we are multiplying with P and then adding the next alphabet. Yeah. So out of 3 approaches, for third approach, if I ask time and space,
Time order of n.
space.
Space is constant, sir.
Constant.
So out of 3 approaches, which approach is easier to code and efficient? 1, 2, 3 wise.
Third approach.
Third approach. Yeah, but it requires that understanding. Okay, it's so simple. I was unnecessarily complicating, coming from right side, pre-computing. Ideally, all 3 are valid solutions. All will get accepted because even in the second, the space is not a very huge requirement, and space is affordable if string length is 10 power 5. But yeah, ease of use is in third. Once you understand, third is more concise and beautiful. So that is what we use as kind of our hashing code. Okay, so now we know how to compute the hash. Okay, before I move forward, sorry guys, I said I'll take 45 minutes, but I may need another 15 minutes. Are you guys okay to continue?
Okay.
Yes, sir. Okay.
Yeah, anyone has any constraints? Did not have dinner, parents holding? No? Okay, so we will continue. Great. So we learned how to compute the hash. That is fundamental thing that will be required. Now coming back to the original problem, if we have to solve. Our problem that I gave you initially was, B, C, D, E, B, C, N. Let's call it that this is the string I'm giving you. What was the original problem with which we started?
Comparing substrings.
Yes, comparing substrings of a string. So you have this string, and your goal is to compute, if I give you this range and this range and I ask, are they same or not? Then we discussed, hey, what we want is, we want hash of this to compute, we want hash of this to compute, we want to compare their hashes, and we want to say, hey, if the hashes are same, they are same substring. If hashes are not same, they are not same substring. This is where entire thing started, correct? And
Yes.
in order to solve this problem, we learned how to compute hashing. hashes. Okay. Now I'm going to take that hash to one next level, and that next level is I'm going to define on a string, I want to define prefix hash. Okay. What prefix hash means is the way we were computing hash right now using third code, that is what we are going to use. So at B level, I want to store B's prefix hash. So I'm going to say B's prefix hash is B into P raised to the power 0. At this moment, when we looked at only B as a character, this is what our H value was. Do we all agree with this? When we started processing left to right in third code,
Yes, sir.
initially H value was this. We said B into P power 0, which is B into 1. And next value, if we have to compute, up to C, if we want to compute the prefix hash, previous prefix hash we will multiply with P and then we add C. So it is like B into P power 1 plus C. Right? In nutshell, if you want to see it as, you can also say this is P power 0. Is that clear? So I'm taking previous value, multiplying it with P and adding current character. So what will be the next value?
Previous value plus
BP square plus
Plus
CP1
P1
plus
plus
D.
DP0
Yeah, D into P0. Okay, next value.
dp cube plus
BPQ plus CP square plus DP1 plus EP0.
Okay, let's write the next few also because they will help us visualize something really good. BP4 plus CP3 plus DP2 plus EP1 plus
bp0.
BP0. Okay, this we have come till B. Let's include two more characters. The next character was C. So we will say BP5 plus CP4 plus DP3
bp3
plus EP2 plus BP1 plus CP0. Yeah, BC was the next character. And last is N. So let's write for N also. So it's BP6 plus CP5,
bp5
DP4, EP3, BP2, CP1 plus NP.
0.
Okay. So if I ask you that I want you to modify this code and you have to give me a long array which is called prefix hashes, and that array should be filled with long n with every hash. So you are able to figure out what modification you will do in this code. So that when for loop gets over, PH is filled, prefix hash array is filled. So what is the change required inside the for loop?
In place of H, we can put PH.
Yeah, but then here also you will have to use PH. So can we
Also
say directly, we
say
can say PH of I is equal to H.
s.
Let H be modified, doesn't matter. We will just store, because every time we move forward, H is updated. Let's store that H in PH of I. This is what you were saying, Pranita? Like in place of
Yeah.
H, just to PH. So rather than doing that, we stored every H value in PH. And now remember, this is what you have. Okay. Now, if prefix hash you have already, you want hash of this part of the string. And you want hash of 4 to 5. So that means you want hash of substring, hash function. You want to define on the string LR, and you also know you have prefix hash available to you. The question is, how can we get it in constant time? This is where we apply the prefix sum concept. If you want sum of these numbers, what do you do? If you want range sum of 0 to 1, what do you do?
pH of L1
Yep.
minus I minus 1 plus pH of R1.
We say this R minus pH of L minus 1 if L is not 0. Correct?
Yes, sir.
For this, we have a better solution so that we don't have to write that if condition also. What I'm doing is I'm going to enhance prefix sum array with one additional number. Let's put 0 here. So this is one additional index I'm adding. Index 0, index 1, index 2, index 3, 4, 5, and so on. Okay. If that be the case, even though L and R are or let me not use that jugglery, that anyways confused. So let's not get there. That we will optimize later. Okay. For now, let's stick to this. pH of R if L is 0. Okay. So here, whatever is the value at C, that is our prefix hash of beginning. Is that correct?
Yes, sir.
Yep. Now, coming to, if you want hash of this B to C, then you will take value at 5 minus value at 3. Correct?
Yes, sir.
So let's see what is the value at 5. So this is value at 0, 1, 2, 3, 4, and 5. So think about if you subtract from 5, if you subtract this, will you get the same answer as BP of 1 and CP of 0? You want BP of 1 and CP of 0. Will you really get that answer? You want this part, BP of 1 and CP of 0. From pH of 5, I'm claiming if we subtract pH of 3 into P square, then we will get what we want. Do you guys agree with me? From pH of 5, you subtract pH of 3 into P square. That means you take this value and multiply every number with P square. Then what you get is the desired hash. Are we in agreement here? Rather than direct subtraction, if we do this, that will be better.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, so this is a little different than prefix sum here. So ideally we will define this should be multiplied with something. And what that something is? P to the power what?
L
L
and
minus R.
It is R minus L plus 1. Whatever is the size of the substring whose hash you are computing. Here you are computing hash of 2-length string, and 2-length string is R minus L plus 1, 5 minus 4 plus 1. So that is what you multiply with. Is that clear?
Yes, sir.
Yep. And in this case, it won't matter. We'll directly use pH of R. Okay. So whatever we have discussed, we have learned. I want you guys to have one exercise where you will create a class of your own. Let's call this class as string hashing. This class should have a constructor. That constructor takes from you string S, and inside this you will define two things. What is P? We took P as 29. What is M? Which we took as 1e9 plus 7. And inside the constructor, you should write some code which can fill our pH array, instantiate the pH array and fill the pH array. And you should write another function to which you can say, get me hash of L2 R. This in nutshell is what we want to achieve. Crux of everything we have discussed boils down to implementing this class. And whatever pre-computation functions we have written, that will go into constructor and get hash, whatever last maths we did, this pH of R minus pH of L minus 1 into P square. That will go into get hash. Yeah, guys, is this making sense to you?
Yes, sir.
Yes,
Okay.
sir.
Now, one more thing is, you will have to compute PP power array also, which was power of that prefix base. Why? What makes me say that? That during pre-computation, compute every power of P also. Why I'm saying that second approach that we discussed was also useful. Where is this PP array going to be used?
Find
In
P power R
comparing string
minus
hash.
L
Well,
plus.
While
while doing the mod, I guess. So
no,
that
when
the
you are computing range hash, when you are computing hash of S from L to R, you see that we had to multiply with P power 2.
yes, sir.
So our formula is pH of LR minus pH of L minus 1 into P power R minus L plus 1. How will you get this if you do not have PP? That means at runtime you will have to compute it. But if we have
Yes.
pre-computed and stored that, that will be used by get hash function.
Hmm.
Yes?
Yes, sir.
Okay. So imagine if you have this string hash class implemented. Then I want you guys to tell me, using that class that we built, first of all, how will you use that class? And if you use the class, what is the time and space complexity of our solution? Using string hashing class that you implement, I want you to comment on time and space. And do not miss out on pre-computation time also. Think carefully, step by step, we build the solution. Okay, Hussein, can you summarize the solution now using our class? How will you build the solution? What you will do?
First of all, in the constructor,
Okay, you
we
will
will
pass the
compute
string to the
our
constructor.
in that constructor. We will construct the prefix hash.
Yeah, prefix hash will be computed and powers of base also will be computed. That will take, can I say that
Computed.
will take n time?
Yes. And for Q queries, it will take constant time. So
Okay.
time complex is n plus Q.
Every query gets answered now in constant time using PP array and using PH array. Okay. Space is how much?
We are storing the powers in an array.
Yep.
Yes. And also prefix hashes. So we will get order of n.
Can I say n for PP array, n for PH array?
Yes. Sir.
Okay, so we have solution n plus q big O wise and space as big O of n. Will this get accepted?
Yes, sir.
Yes, sir.
Awesome. Then we are good. Yeah, so that is what I wanted to discuss. I have a list of 6 to 7 coding problems which are solvable with the help of our string hashing class. So once you implement that class, you will be able to work on those questions. So I'll be sharing the list of those questions so that you work on it, you practice. And this is what I just wanted you guys, since you guys are good coders, I want this one more arsenal to be there in your tool set, that this enables you to solve good number of problems with string hashing. Cool. So thank you, all of you, for sparing this time. I hope it was worth wasting your time today to learn something new.